Welcome dear students. Today we will learn about linear equation in two variables part 4, in which we are going to learn equations of lines parallel to x-axis and y-axis. Before this, what we have discussed, let's see. We have learned solution of linear equations in two variables. Here we studied that when we find the solution of linear equation in two variables, we have infinitely many solutions. For a specific value of x, we can have a specific value of y, but for several values of x, we can have several values of y. So we can have order pair and infinitely many order pairs as solution of linear equation in two variables. Now, and also we have learned how to plot the graph of solution of linear equation in two variables. Now see, how to plot we have discussed, and we have to put the solutions as points on the graph and join those points. And what did we get? We got the the graph of the linear equation as straight line. Today we will learn about the equation of x-axis and y-axis. Let's see where the points 2, 0, minus 3, 0, 4, 0 and n 0 lie for any real number n in the Cartesian plane. Now see, if we plot these points on this graph, what do we see? See, 2, 0 is a point on x-axis. Then minus 3, 0 is also on x-axis, and say 4, 0 is also lies on x-axis. From this, we can conclude that they all lie on the x-axis. But why? Why do they lie on x-axis? Because on the x-axis, the y coordinates of each point is 0. You see, in y-axis, x coordinates are 0, and in x-axis, y coordinates are 0. So we can say that all these points of the form n0, where n is real number, lies on x-axis. Then every point on the x-axis, we can say that they are of the form x0. Now, what will be the equation of x-axis? You see, for any point on x-axis, it is of form x, 0. That means what is 0? 0 is y coordinate. So we can say that y is equal to 0. That is the equation of the x-axis. But here it is a equation in one variable. So how to express it in equation in two variables? We can write like this: 0 into x plus 1 into y is equal to 0. You see, in left side, the whatever value you put for x, you will see the x term will become 0 and y is equal to 0 is the result. So the equation of the x-axis is y is equal to 0. Now let's have a look at the points 0, 2, 0, minus 3, 0, 4 and 0, n. For any real number n lie in the Cartesian plane. Where to find Let's plot the point 0, 2. See, 0, 2 point is on y-axis. And where is 0 minus 3? 0 minus 3 also lies on y-axis. And 0, 4 also lies on y-axis. So, the equation of the y-axis is given by x equal to 0. Because in y-axis, x is always 0, whatever be the value of yb. Now, every point on the y-axis is of the form 0, y. And we can write it in equation in two variables as 1x plus 0 into y is equal to 0. Let's have a look at this type of equation, that is x minus 2 equal to 0. Now, you can see that this is an equation in one variable, that is of x only. Then it has only one solution or unique solution, that is x equal to 2. And if we geometrically represent it, we can get a point on a number line. But this equation can also be treated in the form of linear equation in two variables. And what is the form? The form is x plus 0.y minus 2 equal to 0. As this is a equation in two variables, so this must have infinitely many solutions. As this has infinitely many solutions, they all are of the form 2r, where r is any real number. So, r is the coordinate of y-axis. So, r is any real number, that means x is fixed. What is that fixed value? Its value is 2. So, also you can check that every point of the form 2r is a solution of this equation. Let's have a look at the graph of this equation. See, 2 and 2, that satisfies this equation. At 2 is x is 2 and value of y is also 2. Now see, value of x is 2 and value of y is 3. That means whatever be the value of y, x is always 2 here. So, is it a linear equation? Let's have the graph of this equation. This is a straight line AB that passes through 2 of x axis. So, if we take any point on this line that is of form, which form? See, it is 2 minus 1. This point is 2 minus 1. That means again any point on this line is of 2r. Here r is minus 1. So, as we studied, this is the case. So, what is the value of x if the value of y is minus 5 in this graph? If the value of y is minus 5, as we learnt just that in this graph x will always be 2. So, the point is here 2 minus 5. So, x is always be 2. Now, let's have another question here. What is the value of y if the value of x is minus 5 in this graph? Read the question carefully. What is the value of y if the value of x is minus 5 in this graph. As you learn that in this graph, the value of x will always be 2, so it is not possible to have the value of x as minus 5 in this graph. So as x is not possible, so no such y is also possible. Okay, so as an equation in two variables, x minus 2 equal to 0 is represented by the line AB in the graph, and note that the graph of AB is a line and that line is parallel to y-axis because it is always at a distance of 2 units to the right of it. So wherever you find the distance, it is always 2 units away from the y-axis. Why? Because x is everywhere 2 in this line. What is the nature of the graph of the equation x plus 2 equal to 0 in two variables? So in last question, we studied about the nature of graph x minus 2 equal to 0. Now let's study the nature of the graph of the equation x plus 2 equal to 0 in two variables. The graph AB is a line parallel to the y-axis and at a distance of 2 units to the left of it in our common sense. Why? Because x is equal to minus 2 for any value of y, so that the point on this line will be of form minus 2r for any real value of r. Now see, have a look at the graph. The point here is minus 2, 4. And let's have another point, that is minus 2, 3. That means x is equal to minus 2 here. So we can have the graph of this equation, and another point is minus 2, 2. So the line through these 3 points is AB. Now this is the point minus 2, minus 1, as the value of y changes but the value of x remains same, that is minus 2. So from top to bottom you can see that the value of x is always minus 2, that is this line is 2 units away towards the left of the y-axis. So what is the value of x if the value of y is 7 in this graph? You see, what is the value of y? As we learned, in this case x will always be minus 2, so the value will be minus 2. And what is the value of y if the value of x is minus 5 in this graph? Again, we can say that we can have no such value of y, as x is always minus 2. X cannot be minus 5. So we cannot have such value of y. Now consider another equation, that is y minus 3 is equal to 0. If this is treated as an equation in one variable y only, then it has the unique solution y is equal to 3, which is a point on the number line. Okay. Now if this is an equation in two variables, then we can express it as 0.x plus y minus 3 is equal to 0. This has infinitely many solutions. As it is equation in two variable, so the solutions can be in the form k3, where k is any real number. Also, we can check that every point of the form k3 is also a solution of this equation. Let's have a look at the points on the graph. -4, 3, -3, 3, -2, 3, 2, 3. In all these points, 3 is common, that is 3. So, this is the straight line AB that satisfies the equation y is equal to 3 or y minus 3 is equal to 0. So, this is a graph parallel to x-axis. Now, I have a question on this. What is the value of y if the value of x is 5 in this graph? Here, whatever be the value of x, the value of y will always be 3. So, if the value of x is 5 in this graph, value of y will be 3. Let's have another question. What is the value of x if the value of y is -5 in this graphs? Again, we can say that as y is always -5 in this graph, so y cannot be -5. So, we cannot have any such value of x for which y is -5. So, as an equation in two variable y minus 3 equal to 0 is represented by the line AB in the graph, and note that this graph AB is a line parallel to the x-axis and at a distance of 3 units to the upward of it, that is of x-axis. Now, have a look to this question. What is the geometric representation of y is equal to 3 as an equation? Okay. So, if we consider this is an equation in one variable, as we learnt today, that this is a unique solution y equal to 3. This has unique solution, that is 3, and the graph is geometrical representation means graph. Graph of this can be a point on a number line, and in two variables this is a line parallel to x-axis and 3 units above the origin, as y is equal to 3. Let's have another question. What is the geometric representation of 2x plus 9 equal to 0 as an equation in one variable and in two variable? Now, the geometric representation of 2x plus 9 equal to 0 as an equation in one variable is a point on number line to the left of the origin. Why? If we solve this, we can see that value of x is equal to -9/2. As the point -9/2 lies to the left of the origin, so we can say that this is a point to the left of the origin. And if we consider it as in two variables is a line parallel to y-axis, because it is in the form x is equal to -9/2. Wherever everywhere the value of x is -9/2, and whatever be the value of y, as we learned. So it will be to the left of the y-axis by 9/2 units from the origin. So in this chapter we learned that the equation of the linear equation in two variables, where we can have infinitely many solutions, and by plotting those solutions on a graph paper we will get a straight line. So the linear equation in two variables is named as linear equation, and any line which is parallel to x-axis, it will have y as a constant. The equation is y is equal to some k. That equation represents the line parallel to x-axis. Similarly, any equation of the form x is equal to k represents a line parallel to y-axis. So dear students, today we learned these things. Today this is the time now. Now let's stop it here. Thank you.